Okay, so today we're going to make the transition from a general solution, which is what we did on Friday, to something called a particular solution. Meaning, when we talked about taking antiderivatives, we quickly realized that there were an infinite number of possibilities. Sorry. That's why we stick the plus C on the end of it. Today, we're going to get rid of the plus C using some initial conditions to translate into a particular solution. Hence the reason this is called initial conditions of a particular solution. So, let's start with this. I purposely mixed things up for you a little bit. I have capital F prime of x. And I want to find the general solution, which means I'm going to take an antiderivative. When I take the antiderivative of capital F prime of x, what do I end up with?
Katie said she'd email you. We're on a field trip. Sorry, field trip.
Where'd you go?
Yoga? Oh my god.
Hot yoga?
Yeah.
How awesome was it?
Class did you take? I literally sweat from places I didn't know would sweat. Wait, I didn't mean like those places. I just meant literally like my legs.
Explaining it isn't going to help. Back to the question, if I take the antiderivative of capital F prime of x, what do I end up with? Which one? Capital F or little f? Big F of x, good. Okay, so this problem is, we want to find the general solution, but then we want to use some initial conditions, and the initial conditions is that capital F of 1 equals 0. So, two-step process. The first step is what we did on Friday. Find the antiderivative of that function. How would you find the antiderivative of that function, Anita? Be specific in this case.
Well, I would first change it to x negative 2.
Beautiful. X raised to the negative 2. I like the way you think. Keep going.
And then it would be 1 over negative 3. Because negative 2 minus 1 would be negative 3.
We're doing antiderivatives.
Plus 1, negative 1, and then so then it would be 2, yeah, x to the first power, x to the negative 1.
And what's the number out in front of it? Molly, what's the number out front? Negative 1. Okay. So write it as x to the negative 2, raise it by 1, so that's negative 1, and then multiply by the reciprocal of negative 1. So 1 over negative 1 would still be negative 1. And we get this. That. Okay. Nothing new there. We did that on Friday. Got that plus C there because there's a family of solutions, i.e. an infinite number of possibilities. The twist today is we have some initial conditions. We also know that f of 1 is equal to 0. Now I'm going to plug and chug. The big question is, David, what goes where? The 1 goes where, the 0 goes where?
0 would go where the x is.
Good.
And the 1 would go where the x is.
Perfect. Okay. Put 1 in for x, put 0 in for f of x. Solve that. We get this. We got a general solution. And please that. Okay, here. C turns out to be 1. And then rewrite it so f of x is negative 1 over x plus 1. You don't have to rewrite it as 1 over x. You could leave it as x to the negative 1. I'm more concerned about you getting the right answer versus getting rid of negative exponents right now. Okay? Everybody good? That's a general concept. we go from a general solution with some initial conditions and solve for the particular solution. Okay, only one possibility there. Are we okay with the concept before I do 2 more examples and then cut you loose? Okay, here's the next example. By the way, this process is called finding the differential equation. So going from a function backwards to find out the antiderivative and finding the particular solution. So I've got a nice pretty polynomial, f prime of x is 9x squared plus 4x minus 7, and I have some initial condition there that f of 1 is equal to 5. So start by taking the antiderivative of that. What's the antiderivative of f prime of x? Nope. Yeah, f of x, lowercase f of x. No, bad. All right, what the heck? Hey, there's the answer. It'd be nice if I could work my own technology. Now we're in business. Okay, so f of x. The antiderivative of f prime would be f of x is equal to the integral of 9x squared plus 4x minus 7. Put that in parentheses. Don't forget a dx. So work on a little notation here. That's what we're doing. We're taking the antiderivative of that polynomial with respect to x. So Max, what's the antiderivative of 9x squared?
3x to the third.
Thank you. You want to keep going, Max?
Why not? 2x squared minus 7x plus c.
Beautiful. General solution. And that is f of x. Now using the initial conditions and solving for c. So I'm going to put 1 in for x, set the whole thing equal to 5. So there's 5. That's going to be 3 plus 2 minus 7 plus c. 5 minus 7 is negative 2. Bring that so c is equal to 7. Which means that my final differential equation, f of x, would be equal to 3x squared plus 3x cubed plus 2x squared minus 7x plus 7. And there's my particular solution. Hopefully you don't find that too difficult. Because again, it's just building on what we did on Friday. Well, how can we make it more challenging? Ideas? Alex, what would make that nastier for you? How could I change the problem where you'd be, oh, crap.
That looks as hard as you can.
You think so? Challenge accepted, my friend.
I've been doing it for a day, so.
So you're golden?
No, but for a day, yeah.
All right.
A day's worth of learning.
Uh-huh. Let's see.
Oh no.
Anybody else want to throw out a suggestion? Well, what's one way you always make it worse? Trig, right. What's another way? Fractions. I didn't go fractions.
Radicals.
Radicals would be bad. Imaginary would be really bad. I'm not that big a jerk. I can be a big jerk, but not that big. Okay, so there's our answer. We're happy. How about we throw in some trig? Well, I'll just show you. Then you tell me why it's nasty.
Oh my lord.
Why?
Why did you ruin
That just looks scary. It's not gonna be scary. It's just you're just mean.
So number 1 made it more difficult by putting in trig, and number 2, I'm starting with f double prime, but I want you to go all the way back to f. Go ahead, give it a shot. As a helpful hint, you're going to go from f double prime to f prime. When you get f prime, then use the first chunk of given information. Don't wait till the end. Then once you get that, then you take the antiderivative again. You'll get back to f, use the initial conditions, and solve for c. So when everything is said and done, you've got one function, f of x, and it has no c's in it. Be careful with your trig. How many of you are using the golfy thing? I know it's only at least one person. And no one else.
So fast.
Welcome to another day.
No, I know that.
And I'm sorry, you say something?
Like, the root does not make sense. What?
That was good. Yeah, I want to give you a point for that one.
Well, golf, we see also golf is one
Last
that's
thing we'll
negative.
apply.
Who's missing that we want to blame that on?
I don't know.
Do I get it because I used to go? Part of it. Oh my god.
Well, the problem is then it's going to become like a brown nose fest. Everybody's going to be kissing up to try and get points. Walking like, Mr. Reedy, your haircut looks great. And then you're straight into the homework.
Then you
Yeah,
respond,
that happened
but
after.
no, I got it all done.
Why do you do that?
You're wrong, okay?
I didn't get it.
Like, I'm not
You turn this into like a Mad Max Fury Road type contest. And the lowest one on the totem pole gets killed.
Oh my god. I always want to spec on it. Dude, I take her every Wednesday.
She said once you.
Yeah. Like the zero.
To find out what the C term is.
So you have to do like. So like with.
And then you'll have f prime of x with no C term. Then you repeat the process again to get rid of that second C term.
I don't like.
She's a fine like, and then she
You plug in zero for that.
In the first one I will, yeah, plug 0 in for x, set it equal to 2. And then solve for C.
no, that's just mine.
Like, what am I doing? But I don't zero.
Much confidence.
Okay, fine for 0 and 9. I think negative 3 cosine is 1 half x.
Bloody hell. There.
He was like not having experience with
I just did the x too.
like you had to be doing.
Okay, how we doing? Making progress? Okay. What's the antiderivative of f double prime? F prime
Of x.
of x. What's the antiderivative of 3 sine of x?
Negative 3 cosine x plus 5 sine x.
Negative 3 cosine of x. Antiderivative of 5 cosine x? Plus c. Okay, now, when you're doing this with multiple c terms, if you can keep track of the c's, that's fine. Some people, and in fact, I think if you look in the book, they switch and they change a c into a d for the second one. Or sometimes you'll see them do a c sub 1. I don't really care. We'll be able to keep track of c's as we work our way through. So I know then that when f prime, when we take f prime of 0, that has to be equal to 2. So this becomes 2, and we plug in 0. What's the cosine of 0? 1. So that's negative 3. What's the sine of 0? 0. That disappears, plus c. So c is equal to 5. Or our first c is equal to 5. We'll get another c in a second. Which means that f prime of x is equal to negative 3 cosine of x plus 5 sine of x plus 5. Okay, so that's our particular solution for f prime. Because I can, stop it. She's shining the light in my eyes. Physics at work. Minus 3 sine x minus 5 cosine x plus 5x plus c. There's f of x. Almost home. Second chunk of information is this business. Negative pi is equal to, what's the sine of pi over 2? 1, so negative 3. What's the cosine of pi over 2?
0.
That disappears. Plus 5 times pi over 2 would be 5 pi over 2 plus c. Which makes c equal to 3 minus 7 pi over 2. So my final answer is f of x is negative 3 sine of x minus 5 cosine of x plus 5x plus 3 minus 7 pi over 2. So this stuff at the end is my last c term. And there's two different numbers there. It's still the c term. That's c, or sub c sub 2, or d, or whatever you want to call it. It's the second constant of integration that we find in the problem. And that's about as bad as it gets. I mean, yeah, I could have thrown some fractions in there, but it's not that big of a deal. If you've got the antiderivative thing under control, this should be pretty straightforward. Can I erase this?
Yeah.
So there's our answer. Real quick about slope fields. We'll get to slope fields later. But what happens is, let's suppose you take a function like we've talked about, and you stop at the c term. So we have negative x to the negative first plus c. If you plot all those, you get an infinite number of graphs. So I started plotting a blue one, a red one, a light green one, and it starts to quickly fill up the graph. So we're going to do something called the slope field, where instead of drawing the entire line, you just draw little dashes that represent the slope at certain points in the line. This is fairly confusing now, but it'll make more sense when we get to it later. I just wanted to show you the difference there of what happens as you graph that infinite number of possibilities. Okay. We're done. Day 53. Okay? Helpful hint for you. Unless you don't like kittens.